All right, so our two most popular coordinate systems, you've only ever heard of one of them probably, rectangular coordinates. They're also called Cartesian coordinates, so you might have heard of the Cartesian plane. It just means rectangular coordinates x comma y. So you count, your x's, you count your y's, and you plot your coordinate. So that gives us one way to identify a location of a point in a plane. So the point 3 comma 3 is unique. So there's only one point in the xy plane at 3 comma 3. There it is. That's the only way to get there. So there's only one way to get there. Polar coordinates are r comma theta, and they give us a different way to represent a location. This point right here could also be represented with an r and a theta. The value r indicates the distance the point lies from the origin, just like the unit circle. R is always 1. R really means radius. How far from the origin are you? So to find this point, this would be R. So I need to find that distance right there. That's R. And theta is the angle. So this is theta. So it's two completely different pieces of information, R and theta, as opposed to X and Y. But you can still get to that same location two different ways. The angles measured counterclockwise, yes. Polar coordinates are not unique. So there's actually more than one coordinate that can represent the same location, basically because of angles. So let's say this one isn't 30 degrees. This would be 45 degrees, right? Because it's an isosceles triangle, 3, 3. So if that's 45 degrees, what would be the hypotenuse? 3 squared plus 3 squared, 9 plus 9 is 18. So square root of 18, or what's that? 9 times 2, 3 root 2. This is 3 root 2 in length, and this is 45 degrees, right? So I would write it 3 root 2, comma, 45 degrees. Well, there's infinite ways to get to a 45-degree angle. I could go 3 root 2, and I could go negative 315 degrees, and I could land at the same spot. I could go 3 root 2, and I could go, it would be 360 plus 45, right? So 405, and land at the same spot. I could represent this with radians, pi over 4. So there's a lot of different ways to get to the same location, which is different than x comma y. The other thing is it gives you the direct way to get there. So if you were walking in a city and you had to walk like east, 3 blocks and then north 3 blocks to get there, a bird would just fly there directly. So you might want to know the distance just to get there directly, as opposed to like walk all this way and then walk all this way. All right, so plotting polar coordinates. These are new polar graphs that you probably haven't seen before. Most of the time, I'm not going to give you polar graph paper. We're just going to use rectangular graph paper and kind of estimate, but it's kind of cool looking. But first, you have to determine how many degrees each spoke represents. See how there's fewer spokes here, there's more spokes here, there's even fewer spokes here. So you need to know what angle those spokes are representing. And then if it doesn't fall on a grid line, just estimate. So obviously, if it was 37 degrees, there's no grid line. You have to estimate. It's between this and this. And I'm going to show you what a negative radius is. So I could actually go in a negative direction. So even though a distance is always positive, I can do a negative r value. So I'm going to show you what that means when we plot these points down below. The x-axis, we're probably just going to call the x-axis because this is like literally 4 days crash course. But in polar coordinate, geometry or whatever, they call it the polar axis. I'm not going to make you memorize that it's called the polar axis. The y-axis they refer to as the line theta equals pi over 2 because that is pi over 2 radians. So that's like the fancy word for polar. Instead of calling it the x and y axis, that doesn't really make sense because we don't have x and y coordinates. They call it the polar axis, and the line theta equals pi over 2 because it fits their coordinates better. I don't really care that you know these words, but just vocabulary to be aware of. All right, so if I want to plot the point 3 comma 30 degrees, these spokes look like they are 30 degrees, right? 30, 60, 90. So I'm just going to go 3 radii out from the origin and go to 30 degrees. So start at the origin and just count 1, 2, 3 radii out, and that's where that point A would be located. So it's pretty easy to graph because you guys just got reviewed on your angles in the unit circle. So 1, 210, I'm going to go all the way over to 210, just past 180, and that's very close to the origin. It's just 1 radius out from the origin. Does that kind of make sense how to plot those? All right, so I want you to do example 2, and then hold up before you do example 3 because there's a negative R value. So just try for yourself plotting example 2 for just a minute. So first I had to figure out, okay, this is different polar graph paper. I had to figure out these were 15-degree spokes. So I know 45 has to be the one that's cutting the first quadrant in half. So I went out 2 on that one. And then I figured out, oh, okay, this is 15. So 300 would be 2 spokes past the 270 mark. And then I went out 5 from the origin. So to me, these are definitely more challenging, figuring out the spokes and, where to plot them. Okay, so a negative R value. So a negative R value basically tells you to walk in the opposite direction. So what you're going to do is you're going to go to 100 degrees. So 100 degrees would be just past 90, right? Somewhere in this direction. So instead of walking at the, 100, I'm going to pretend this spoke is 100 degrees. So instead of walking 2 radii in the 100 direction, I'm going to walk 2 radii on the opposite direction of that line. So if this spoke was the 100, I'm starting at the origin and I'm walking away from 100. So you don't have to figure out which angle this is because it's going to be directly across from the 100 angle. It would actually be at what, like negative 80? All right, and then so this is A when it's negative. And then if I'm going to 2, 100, I would be going right here. So I'm actually walking on the 100 line in that correct direction. In example 4, there's 2 different negative signs. This is a negative angle. This is a negative R value. The negative angle you treat the same as we've always treated negative angles. It just tells you to go clockwise instead. So if I go clockwise 180, I'm still over here on the negative x-axis, just like I went positive 180. So I'm just going to go 4 units, 1, 2, 3, 4 on that negative x-axis. So that would be point C. And then D wants me to go 180, but then walk in the opposite direction 2 units. So 180, I would have been walking in this direction. So to walk in the opposite direction, I'm actually going to walk on the positive x-axis 2 units. So just a negative R value tells you to walk in the opposite direction. And that is up here. A negative radius means terminal side goes in the opposite direction. So that's what you need to know about plotting them. So on your test next week, your 50-point polar coordinate test, there'd be a couple questions like what you're doing on the quiz tomorrow, the evaluate trig functions. And then there'd be a question where you have to plot some polar coordinates, maybe with negative R values or negative angles. And then the next thing is actually taking a rectangular coordinate, like I basically just did for you, right? This was taking a x comma y and converting it into polar. All I used was the Pythagorean theorem, right? So here's how can I plot negative 3 comma 4 and convert it into polar form. So first thing, I like to plot it first so I can see where my triangle is. So here's negative 3, 1, 2, 3, 4. So here's the point I'm interested in. I like to make it into a right triangle because that's all that it is. So I need to solve for this angle and this R value. So you don't have to memorize this process. You should already know how to do this next step from trig last year. If this is negative 3 and this is 4, this is just a 3, 4, 5 triangle, right? 3 squared plus 4 squared is 25. So R has to equal 5. So it says R is the distance the point lies from the origin, so you can use the Pythagorean theorem. And they wrote it x squared plus y squared equals r squared. So what you're really doing is you're taking the square root of x squared plus y squared. That's what you do to solve for this. So 9 plus 16, take the square root, r is 5. So it's just practicing trig Pythagorean theorem. How do I find the angle? So the angle is using inverse tangent ratio. So it says theta is the angle the ray connects and makes with the positive x-axis. So this angle is actually what I'm looking for to get there, but I can only solve in a triangle for the interior angle. So once you solve for your triangle, this is really the angle of interest to get there, right? So it says you can find theta by using the tangent ratio. So tangent is equal to y divided by x, right? Because it's opposite over adjacent. Opposite is going to be your y value. Adjacent is going to be your x value. So I just think of it as y divided by x. So we're looking for the tan inverse of y divided by x. I don't even worry about using like negative 4/3 because I have to figure out at the end what this actual angle is. So I do it in degrees. So I make sure I'm in degrees, and if not, you can change that with the mode key. And you just go to second tan inverse, so it's over the tangent button. I just do 4/3 if it were me, not worry about negative 4/3. So the reason I don't worry about if it's negative, I'm finding the interior angle of a triangle right now. So 53 is not my final answer, or 53.1. 53.1 is this angle right here. I'm interested in this angle. So based on what quadrant you're in, you're going to have to do a little bit of math yourself. The calculator's not smart enough to tell you to get to your location. You need to take 180 and subtract 53.1. So the real angle here should be 126.9 degrees. So it takes a little bit of, problem solving. You've got the tangent key. You need to figure out, what you're plugging in, what you get, and what it means based on what quadrant you're in. So that's why having trig before this course is important. Does that kind of make sense, the process? Shouldn't really be memorizing a whole lot of new stuff. It's just using your trig facts like in a new way. So for 2 of these examples, we are going to do them the way that we just did up above. But for 5 and 8, you shouldn't need to do a whole lot of work. If you are at 0, 5, you're right there. Don't you already know what angle that is? Don't you already know how far away from the origin you are? So what is r and what is theta? You don't need a formula to tell you that. R has to be 5 and theta has to be 90. So I didn't have to do the Pythagorean theorem. I could have. I could have figured out the tangent using the tan inverse key. But to me, it's easier if you can identify the quadrantal angles like 0, 5. I just plot it, figure out how far away I am and what the angle is. Example 8, I plot it again. Negative 10, 0 is over here. So what is the distance? How far away? And what is the angle? Your distance is what? 10, right? I'm just 10 away. 10. And my angle would be 180. So then it says for each example, change it to polar and give a second example of a polar coordinate that would represent the same location. Can you give me another polar coordinate that could also get me to 5, 90? There's a lot of possibilities. Give me another one that could work. Sure, 5, 4, 50. That would work, right? I've gone more than once around. I could go backwards, right? I could go 5, negative 270. I could even go negative 5, and then I'd have to go what? 270? because then I'm going in the 270 direction, but I'm going in the opposite direction so that I'm going up. There's a lot of possibilities there to write a second idea. This one, I mean, the easiest would just be 10 negative 180, wouldn't it? Get there by going clockwise instead. All right, so on 6 and 7, we need that Pythagorean theorem stuff. How far away am I? So R, you're going to use the Pythagorean theorem. So 2 squared plus 2 squared. I just ignore that it's negative because to me it's the side of a triangle, so it's a distance being squared. Comes out positive anyway. That just gives me 8, right? So the square root of 8 is my distance. If you feel more comfortable leaving it as the square root of 8, go for it. I just am trained to reduce that to 2 root 2. Square root of 8, I'll count correct. So if you mess up this step, just stay at square root of 8. All right, so square root of 8. And what's my angle? So I like to plot out where I am. So I'm at 2, comma, negative 2. I'm down here with an isosceles right triangle. You should know what that angle is then. Any isosceles right triangle has an angle of what? 45. But how am I going to represent this location? I can't just say 45 degrees. Negative 45, 315, right? Either way. So negative 45, or you could say root 8 and 315, because they want you to write 2 different ways anyway to get you to the same location. And then example 7 is not going to come out as a perfect angle. You'd have to use a calculator for example 7. So example 7, if I'm at 1, 5, here's my triangle. So 1, 5, I'm going to find the hypotenuse and then do tan inverse to find the angle. So I'd like you to try example 7 before I tell you the answer. See if you can do Pythagorean theorem and find the angle. And 78.7 degrees because I'm just in quadrant 1. So I could just take whatever it told me on my calculator, right? Tan inverse of 5. 26 isn't reducible as a radical. I would just leave it as a radical because that's the exact distance. If you want to take the square root, 5.1 is fine. But does anyone have questions on example 7 before you try 9, 10, and 11? So I'm going to have you try 9, 10, and 11. For the sake of my video. 9 was the same, so we crossed it out. And then did you get root 60 or 2 root 15? And then 56.3 is your angle. And then I realized 11, why does that angle look familiar? Well, we just did it up here, right? A 4, negative 3 triangle is going to have the same as an 8, negative 6 triangle. The only difference is going to be our R value. And 6 and 8 are a Pythagorean triple with 10. So 6, 8, 10. So is that what you ended up getting for 10 and 11?